Good evening, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, June 13th, 2018 edition of our little weather get-together. This is show episode number 236, and tonight we have Kenneth Hudnut. He is the Science Advisor Risk Reduction folks with the USGS, the United States Geological Service. So we're happy to have Kenneth on with us tonight as our guest, and Kenneth is joining us from beautiful Hawaii, and I think he's going to tease us with a view here in just a little bit. But we're happy to have Kenneth on with us tonight. This is a live broadcast, so we do ask you to interact with us tonight. You can do that one of many different ways. We have Facebook Live and Periscope streaming right now, as well as our YouTube video. So if you are watching tonight and you have any questions for our guests, please feel free to interact with us. You can do that via Twitter, Carolina WX Group, or send us a Facebook message or even comment on the YouTube page, and we will monitor those throughout the show. And if we have any questions, we will present them towards the end of the show. And if you're listening on our podcast, maybe a few days from now or at the end of the show, that way you can direct any questions you may have for him there. So again, this is a very fun show. Looking forward to it. Although earthquakes are not really weather in the weather realm, we do talk a lot about earthquakes because it seems like meteorologists are faced with earthquakes and volcano questions just as much as weather questions. So we're going to be learning just as much as you guys are tonight. Before we do get into our discussion, I do want to quickly hand it over to Shay Gibson, who will give us a quick tropical report. It looks like, Shay, things are starting to maybe get a little bit active in the tropics.
Yep, I'm going to go ahead and present this. Right now, the only thing we have, let me know when you can see the screen that I have here. Everybody good?
We got you.
Okay, good deal. Right now, the Eastern Pacific has really come to life in the last several days and last week. And we have another area of disturbance. We already had Aledo. Now we have Bud, which is quickly diminishing to a tropical storm. It's expected to be a depression by the time it makes landfall somewhere along the southern Baja Peninsula right here. It doesn't look like it's going to be too big of a threat as far as winds, but rainfall is going to be the issue here, as parts of Mexico, especially the Baja area, these parts of Mexico are prone to mudslides with heavy rain. So there'll be some advisories on that as well. The winds are 50 miles per hour, pressure at 998, and it is moving north-northwest at 6, and it is expected to continue weakening because it's over cooler waters. Now behind that, another area has a pretty good chance for developing. And this is a 60% chance next 48 hours and 5 days. So we'll be watching for that as well. If we hop over here to the Atlantic, there's only one area of disturbance. The Atlantic's been pretty quiet. We have cooler waters over the main development region, or the tropical Atlantic, along the equatorial areas. And so we're not seeing a whole lot of development there. And we probably won't for some time to come. There's also Saharan dust aloft in the atmosphere at the mid-levels that's also killing off any sort of significant troughing or tropical waving coming across the equatorial region. But we have this area of disturbance over here in the Western Caribbean that's just now making its way over the Yucatan. Very low percentage. Now, the GFS had sort of built on this a few days ago, and it sort of brought it up to the Louisiana coast and slid west into Texas. But now that's not the case. It looks like this whole thing is going to continue to move to the northwest or west-northwest very slowly and possibly move into Mexico. But it only has a 20% chance, and that's going into this weekend and maybe early next week. So conditions may be more conducive for development later this week. We have yet to see until it pops out over the Gulf of Mexico. And if we look at this, it's very poor organization. We just don't see a lot. Look at all this upper shear going on from west to east, or from northwest down to southeast. And there's no surface circulation or low-level circulation to speak of. There's a lot of convection over the Yucatan Peninsula, but nothing really concrete to see out there. Just a lot of storm activity and rain. So the Yucatan Peninsula is getting a significant amount of rain right now. But otherwise, the tropics are pretty quiet, and we're just enjoying some decent southern weather here in the southeast region, and nothing to speak of for tropical activity for now. So back to you, Scotty.
Thanks for that, Shay. And I guess you and Jared and myself will all be preparing for what looks to be like a heat wave moving into the southeast late weekend into early next week. Maybe we can talk about that towards the end of the show. But since we did get kind of a delayed start because of what else? Technical issues. Imagine that. Let's bring in our guest tonight, Kenneth Hudnut from the USGS. Kenneth, welcome to the Carolina Weather Group. We're happy to have you tonight.
Thanks very much for having me.
You're welcome. So tell us, before we kind of get into our discussion tonight, one question we always ask our first-time guests is kind of give us a little background about you and maybe what got you interested in studying earthquakes.
Oh, it's a little bit of a long story, but when I was a kid, I was just interested in rocks, and part of that was because where I lived up in northern New York at that time, there were garnet tailings that we would use to put gravel down on the roads, and so you could find garnet pieces in there, and I would bring those up to my grandmother, and she would put them on the windowsill so the sun would come in, and she called me Hawkeye. So I liked that, that I just kind of interested in picking up rocks, and looking at them, trying to figure out what the different ones were. So that started at a pretty early age for me. And my other grandmother was a PhD biochemist, and she kind of got me interested in science in general. And geology, I guess, my mom signed me up and she did it with me, but there was a geology program at the planetarium in Rochester, New York. And I learned about geology by going on field trips. And we did things like we went to a railroad road cut where there were fossils, and that was really cool. And then we went to a salt mine, and you could take the big hunks of halite out and break them down smaller and smaller, even look at them under a microscope, and saw that the big chunks are cubes, and you break it down even smaller and it's still cubic because of the mineralogy of it. So this was when I was pretty young. And then when I was in college, I tried out a class my freshman fall, and I really liked it, and had a great professor and got very excited about it. And then when Mount St. Helens went off, I knew I wanted to study this and try to connect my interest in doing societally relevant work with my interest in geology. So I went on, studied volcanoes through my undergraduate years. When I switched to do graduate work, I had all lined up. I was going to study this volcano in Alaska called Pavlov, and that had funding from the Department of Energy. But after my first summer of fieldwork in Alaska, I was all set to keep doing that. But the DOE funding stopped because they decided they weren't interested any longer in trying to find geothermal resources out there at that time. And so I had to switch to my second project, which was the San Andreas Fault. And I've been doing that ever since, basically. Until right now, I'm in Hilo, Hawaii, and I've been deployed to bring some LiDAR technology into the response here. We're going to be using that to study the Kilauea eruption starting in a couple days here. So, for me, it was kind of like that, how I got into it. And as far as my family and my upbringing, I was born in Oklahoma. My dad was in public health service, and we moved around quite a bit when I was little. My first memories are from Moorhead, Kentucky. I remember the honeysuckle and the fireflies, and then we moved to Rochester, New York, and then Glens Falls, New York. So kind of bounced around. I went to high school there. My parents still live there, and my grandparents lived there. But my wife and I, we moved out to Southern California in 1989 and raised all three of our kids there.
And so, Kenneth, you were born in Oklahoma, so I guess that kind of gives you a little weather experience as well, as it's always crazy out there.
Yeah, and it's turned into quite the place for earthquakes too.
It has. I go out there every year for severe weather conferences, and I've never felt an earthquake out there, but they're always talking about how they're so numerous out there. So crazy thing.
Yeah, well, there was a big football game going on, and I may get this wrong a bit, but I think it was Herb Street that was reporting when the earthquake shook, and they got that on video. Wow. I guess, they're more and more frequent and larger, so been as high as magnitude 5.7 earthquakes. And this has caused my agency, USGS, to actually go about making an amendment to our normal lower 48 U.S. Seismic hazard map. And now for east of the Rockies, we do an annual update to that because the probabilities of earthquakes are changing as things are changing east of the Rockies. There's quite a very noticeable uptick in seismicity east of the Rockies. Now, this is not all just naturally occurring like the Mineral, Virginia earthquake back in 2011 that probably a lot of your listeners back east felt, but also it's associated with oil and gas production methods changing. And basically when they extract fluids from fracking and then re-inject those waste fluids deeper and at higher pressure. That can be associated with earthquake activity changes. And so this has all been studied carefully by my USGS colleagues in Golden, Colorado.
And I know you have a presentation for us, and I want to get to that here in just a second. But for our followers and listeners who may not be familiar with the USGS, could you tell us a little bit about what they do? Because I know you guys are involved in a lot of things throughout the country or throughout the world, honestly.
Yeah, we're multifaceted, that's for sure. Our primary mission is scientific, and we're an objective scientific agency with no regulatory role at all. So people just expect us to do good science, and that's what we try our best to do. We were formed by what's called the Organic Act back in the mid-1800s. Our early directors included John Wesley Powell, who was a noted scientist and also had been a Civil War veteran, so one-armed guy who made a wild ride down through the Colorado River Canyon, just as a scientific expedition, but in the early days, just as tough as they make them, he was a great one. So just a long storied history of our agency, very proud to be a part of it. I'm in the part called Natural Hazards. We also have a part that I'm working with right now on this rapid LiDAR stuff where it's called National Geospatial Program. So we're also responsible for mapping. We do topography. People that maybe older people like me remember the paper maps, the topo maps, and nowadays people have pretty much moved on from that, but we still have what's called the national map. So we provide imagery mapping for the nation. We're now doing a project called 3DEP, which is LiDAR for the nation, working with states to basically get statewide coverages all in and then into a uniform format such that people can get all that great data and information at their fingertips wherever they are. And USGS also has a big part that does water, and we have other parts of USGS, including biology. We have a very broad program of science that we are responsible for. And as a federal agency, we're kind of on the smaller side. I think our total number of employees are around 8,000 or so, and we're spread out across the nation with a lot of field offices. I'm based in Pasadena, California. That's since 1992. Our earthquake program office in Southern California has about 30 people, and we do all the earthquake monitoring for Southern California from there.
That's some great information. And so you've been working on a project called the Haywired project, talking about earthquakes, especially in California, Southern California. And I know you have a presentation, so I'll give the microphone per se to you and let you start with our presentation. And Shay and Jared and myself will watch and definitely have some questions.
All right, very good. Well, because I mentioned that I'm here in Hawaii, I'd like to just start out by at least trying one thing real quick here, which is I want to share the view out my hotel window with all of you. This is one of the few hotels with rooms available at the government rate that a whole bunch of us are in here working on the Kilauea incident from this amazing place. But you can see that nice view out there. Just wanted to share that all with you.
That is gorgeous. Now, what body of water is that over there?
Hilo Bay.
Hilo Bay.
Yeah.
Very nice.
We're out here in the middle of the Pacific, and it's just gorgeous. But we are working our tails off. It's not like I'm getting to enjoy it all that much, but you see the artwork on the wall behind me too. It's just wonderful. I love Hawaii, and I have friends here in Hilo that grew up here. So it's been great connecting with them. One of my friends, her dad used to be head of emergency management over at Civil Defense here. So I'm feeling so welcomed by the great people here. Now I just wanted to start out by, I'm going to try sharing my screen here. You're asking about, the kinds of things that USGS is responsible for, and I thought I'd kind of launch into this by sharing. I hope you can see this. I'm going to try to get it up to full screen here. This is the U.S. Lower 48 map, and you can see Alaska and Hawaii tucked in on the sides there. Are you able to see that okay?
Not yet. It has not popped up on our screen yet.
Okay. I'm doing something wrong.
Sometimes the full screen option does not work with that, with PowerPoint. We have seen that before on the show, so that could be one of the things that's stalling it. There you go. So now it's up. We're good.
Yeah, it was actually just user error. I needed to actually hit the button. Good. Okay, so yeah, this is something to just introduce people to the overall seismic hazard map of the U.S. You know, you can see up there in Alaska, it tops the charts in terms of hazard. Alaska has tremendous earthquake hazard. The 1964 Alaska earthquake was one of the largest ever recorded. And then, of course, in 2002, we had a 7.9 earthquake on the Denali Fault as well. Down in the lower left, you see Hawaii, where I am right now. The big island of Hawaii has had big earthquakes in 1868 and in 1975. And then, of course, also up there in the top ranks is California, but really the whole West Coast. Now, as we move to the east, where you all are, and maybe many of your listeners are, you get into, it looks kind of like polka dots, right? Where that big one right there in the middle is New Madrid, Missouri, where we had a big earthquake sequence in 1811, 1812. And then you see down there in the lower right, you see here we got a cover of this report, Charleston, South Carolina. There was an earthquake in 1886 that's most recently been re-estimated to have been about a magnitude 6.9. And so here I'm just showing you the cover of a USGS report about that earthquake.
Interesting. So, you say re-estimated, because I think that was originally an 8.0. Is that correct?
Well, see, that's the thing. It's really hard to know with those old historical earthquakes, and we can talk about that. But basically, we have newspaper accounts, and it's sometimes the case that people who experienced an earthquake were in a, say, a low kind of riverbank area where maybe the ground motions were amplified. So in more recent methods for estimating magnitude, people try to take all that into account when they essentially try to calibrate the written reports from newspaper articles. Several of my colleagues work on this. Sue Huff at my office in Pasadena works on that. In that particular case, that 6.9 plus or minus 3 estimate was from Oliver Boyd for the 1886 earthquake. But that occurred at 9:50 p.m. on August 31st in 1886. And so if people are interested in learning more about that, there's this USGS Circular 985 that was done 100 years after that earthquake occurred. And with all of the reports that USGS does, we make them all openly available online so that anybody can read them. A lot of our reports, we try to do them in a way that's relatively speaking jargon-free compared to most of the scientific literature. And you know, so they're not behind paywalls, they're openly, freely available. And so that's one of the things I just want to mention about the kinds of products that we put out there. We're trying to communicate to people that do not necessarily have a science, technology, engineering, and math type of a background, you know, that people that can handle very high level content, but just it needs to have the jargon removed from it for people to be able to understand, even if they don't have that specialized background. Coming back to the U.S. National Seismic Hazard Map, the other point I wanted to make about East Coast seismicity is, I hope you can see my cursor here as I move it around, but where we have these large splotches on the hazard map in the east, it's where we have had big historical earthquakes. And where we have not had big historical earthquakes, the map is colored with less intense colors, like say green or blue. That's not to say there's no hazard there, but it's just a lower hazard. So what we are trying to reflect here is that where we have had big earthquakes, we could have more big earthquakes. It's just a different way of stating essentially like an aftershock hazard. So it might seem surprising that we would be concerned about essentially large late aftershocks from these historical earthquakes, but that is still possible. And we also have belts of seismicity where we've noticed that we record smaller earthquakes. You know, you've got the Mineral Virginia earthquake as well, and up here in northern New York. Now, some of this is just not really very, very well understood, why we have earthquakes in older crust, but it tends to be probably where there are stress concentrations, where there are fractures that are accumulating stress. And One of the things is the unloading of the glaciers, believe it or not. That has been associated with uplift of the crust, which can then cause stresses. So there are a bunch of different theories. I just wanted to give a quick sketch of that, but certainly there have been important and very damaging earthquakes in New Madrid, but also along the eastern seaboard, many historical earthquakes. And so the Mineral Virginia earthquake of 2011 was a kind of a shocking reminder, but it shouldn't have come as anything too surprising for folks, because we have had a long history of East Coast earthquakes. And Northern New York, the Messina earthquake, I'm just giving you some words that you can search on later if you'd like more information, or we can circle back to them. But of course, the biggest event in recent time was the 5.8 August 23rd of 2011 in Mineral Virginia. Here, I hope you can see that photo, but it shows some damage. Now, I'll just take a moment and say, whether it's Mineral Virginia or someplace in California or any place in between or anywhere around, it's often the case that we'll see chimney damage. Chimneys just peel off and fall down. And if they're internal to the house, they can often snap and then fall down through the roof and sometimes kill people. But chimney damage is just prevalent. And so there is actually a FEMA guideline for anybody that would like to consider mitigating the potential for having a chimney damage in a future earthquake. So that's, of course, not the only kind of damage we get, but it is prevalent. Now, on this website that I'm showing you here, if you go to earthquake.usgs.gov, you'll find a tremendous wealth of information there. Here you've got, along the left-hand side, you've got a list of different earthquakes, special reports on them. I mentioned the 1964 Alaska earthquake. There's a special page about that one. Some other famous ones, of course, are notorious. April 18th, 1906 was the great San Francisco earthquake and fire. You introduced with the Haywired scenario, which I'll come to in a moment, but the last big earthquake on that fault was in October 21st in 1868 on the Hayward Fault, and it was about a magnitude 6.8. So we do our best to interpret and write reports on and understand these, historical significant earthquakes. We do that as a way of understanding the future hazard, and then we communicate that to the public by our one of our main products being the U.S. National Seismic Hazard Map. That now I got confused about which window is which, but the one we were looking at before, there it is. So this is our way of putting all that information together, and you can see here, of course, if you're trying to decide where you might want to move to get away from the earthquake threat, then you might be looking at places that have other kinds of natural hazards, whether it be, you mentioned about Oklahoma with the tornadoes there. Well, other places, hurricanes. So in places where the earthquake threat is low, some other type of natural hazard threat might be high. I don't have it right in front of me to grab it right now, but there are maps that colleagues of mine have made that combine all the different kinds of natural hazards and put it into a single map. So this is just that earthquake slice. It's one that I study, so of course I care about it, and happy to be here and answer questions for your audience about earthquakes. So yeah, California, I guess pretty much everybody knows if they move to California, they're going into the thick of it with the earthquake threat there. Pacific Northwest, maybe not as many people are familiar with that being a problem there. It was really in the mid-1980s that people recognized the earthquake threat in the Pacific Northwest. And there was the Nisqually earthquake up here not so long ago, which also was a reminder. That was a deeper earthquake, so the shaking wasn't quite so bad as if it had been shallow. When you have a deeper earthquake, imagine the energy is radiating out from the source point of the earthquake. If we refer to the map view projection of where the earthquake occurs, we call that an epicenter. If we talk about the point at depth within the earth where the earthquake starts, we call that the hypocenter. So in the Nisqually earthquake, down at around 50 kilometers deep, down in the slab that's being subducted underneath that west coast, that slab where it's going down, it's still cold enough to have earthquakes occur within that downgoing slab of the subduction zone. Sorry if I'm bringing in some plate tectonics terminology already here without warming everybody up to it. But that Nisqually earthquake was deep enough that as the waves were emanating from the hypocenter. As you go up from 50 kilometers depth toward the surface, imagine that the waves are diminishing in amplitude as they approach the surface because of an effect we call geometrical spreading. So that's the same thing as if you have, say, an explosion and you're distant from it. By the time the waves get to your location, they will have decreased in amplitude. And it's the same kind of an effect, that geometrical spreading. Another thing I want to mention while we're looking at the National Seismic Hazard Map here is there's a big difference between how earthquakes are felt in the east versus in the west. So if you have the same magnitude earthquake in California and in the East Coast, like the Mineral Virginia earthquake, that earthquake was felt over a much wider area than an earthquake of the same magnitude if it happened in California. And the reason is that in the east, you have old rock that's harder and it does not damp out the seismic energy as quickly. And so the earthquake shaking is experienced over a larger area. I'm going to show you now from the Mineral Virginia earthquake, whoops, that was a smaller one. Got an issue there with our links, sorry. Well, instead of trying to show you that right now and fishing around for that link, I'm just going to revert back to some of the other contents here. What I wanted to show you.
Basically, you're saying that the type of rock is directly related to the power or intensity of earthquake with its aftershocks.
Yeah, that's right. Yeah, the shaking falls off more quickly with distance in California because of damping and what we call attenuation. And in the East Coast, it's more like ringing a bell, and the waves get transmitted. The energy propagates much farther and more efficiently in the east. Is the screen share still working okay? I see it, yeah, New Madrid seismic zone. So this is just letting you know that there's a ton of information available. This website here, we've got, here's a poster with 20 cool facts about the New Madrid seismic zone, and another poster about the bicentennial of it, and a fact sheet. So just real quick here, you see some summary information about that earthquake sequence, even photos, eyewitness accounts. So just a wealth of information that we put out about earthquakes throughout the United States. It's really not just a California problem. And in recent time, there was an article in the New Yorker about the earthquake threat in the Pacific Northwest, and a whole lot of people read that and took interest in that as well. And I would say for the East Coast, what was really the wake-up call about the earthquake hazards back there was that Mineral Virginia earthquake. So I feel like we've kind of covered those topics pretty well. I'm going to close some windows here, simplify my desktop a little bit. And let's see, we talked about that as well. Charleston, South Carolina, who would have thought in terms of earthquake country that places like that or Oklahoma were places with a significant earthquake threat, but they are.
Yep, I wanted to ask you about that too, because it looks like Oklahoma is sort of a new and up-and-comer when it comes to tremor activity, earthquake activity. You mentioned Colorado earlier, and it seems like there was maybe some belief or some theory that fracking was causing some of these earthquakes, and the companies that are doing it are saying there's no way it's possible. But now we're starting to see that it's not a theory anymore, that it is really occurring. And fracking is a direct result of some of the earthquake activity you're seeing in Oklahoma, Colorado. Scotty, we had a guest on a couple years back from Oklahoma that talked about the increase in the tremors and how much the cities and townships and the counties were willing to put up with. And it just boggled my mind, like how in the world, why would they let this happen? But so tell us a little bit about your experience with fracking and earthquake activity.
Yeah, this is not something that I study myself, but some of my USGS colleagues have written extensive reports and articles about this topic, and it's very interesting. It can be contentious. I mean, our role is just purely to do the science and leave it to others to figure out things like the policy or whatever. Like I said, we're non-regulatory, but what we do is we monitor earthquakes, and so when things change, we sure notice. And then we also work with our state counterparts to figure out, and oftentimes it's other people, not us, that are going to figure out what to do about it, if anything. There have been significant earthquake sequences that kind of started suddenly where there had not been historical activity before, also in places like Arkansas, Ohio. And so sometimes these are associated with industrial activity of one kind or another. Basically, injection of fluids at high pressure at depth can, but are not necessarily associated with earthquake activity. It's all the kind of thing that you can apply the scientific method to study it and understand it, and that's what we do.
Understood. Understood.
Yeah, there's all kinds of examples where, even in Colorado, some of the earthquake activity was associated with a variety of industrial types of activities, and also just basically moving around fluids under pressure. It can cause the fluid pressures to change and get concentrated and lead to earthquake triggering. So this is something that's been studied intensively in a project at USGS that looks at induced earthquake activity. So some of my colleagues would be the better ones to talk with about that topic. I'm familiar with it, but only because I've read their work.
Understood.
Yeah, I think it's a fascinating subject, and one where I guess my perspective is I have this feeling in general, and I try to communicate it just as clearly as I can, but basically a lot of things are manageable, and engineering solutions can be used for an awful lot of things, and sometimes it's just a matter of if it's an engineering solution that's required to some problem, the reason you might not want to do it is just simply cost. There might be some engineering solution, but it might be too costly to be able to do it. In terms of management, there's a lot that can be done to, throttle the rate at which fluids are being injected, that kind of thing. So there are management approaches to a lot of those kind of issues.
Gotcha. So when I spoke to you some weeks back, we talked about some of your primary focus was on the West Coast and in the San Francisco area. Tell us a little bit about what's going on with the San Andreas Fault or in any kind of earthquake activity. There was a lot of buzz in the news a couple years back there was a series of earthquakes, a series of sort of indicators that something big was coming. Is that still the case, or are we sort of just continuing to monitor at a normal pace? Is that kind of the motto these days, or are we on a heightened alert?
Well, there has been news media buzz at times. I remember when we had a series of earthquakes back in around about 2010. We had the earthquake in Haiti. We had an earthquake in Chile. We had the earthquake in Japan in 2011. And so earthquakes were really on people's mind, and some people in the news media were spinning that a certain way. But colleagues of mine studied that and looked at the statistics and concluded that it was within the normal variation that we've seen historically. In other words, the global earthquake activity rate fluctuates through time, and that's just normal and natural. And there wasn't anything particularly unusual about what was going on at that time. And so sometimes people think we're maybe sounding a little dismissive when we say such things, but really what it is just applying the statistical methods that we feel make the most sense. And colleagues of mine who do earthquake statistics have reached these conclusions and written up papers that are technically, beyond reproach, that conclude that no, there's nothing really unusual. And it might seem a little disappointing to people that they maybe see a pattern there. We get a lot of input from a lot of people who are wanting to make sure that we know that they think they have predictive abilities when it comes to earthquakes. But as far as we've ever seen, doesn't work. And there have been extensive reports written about all of that as well. Probably the most impressive, I would say, was a report that was done as a result of a commission after the earthquakes in Italy, in which case it was felt that the scientists were accused of manslaughter, and so this was played out through the Italian court system, and these were colleagues of ours, and so this has all been written up in extensive reporting. If you want to search and read more about all of that, the journal Nature did a really thoughtful series of pieces about earthquake prediction, just really describing the whole status of earthquake prediction in general. And I'm going to try to do a quick search on this topic for you to show you what I'm talking about here. but there was a earthquake forecasting commission report by Tom Jordan and a group of others that was a very impressive publication that'll probably pop right up. Yep, Annals of Geophysics right here. So this was published in 2011, and this is a definitive resource for anybody that has any questions about earthquake prediction. I would guide you right here. So by searching as I did just there, earthquake forecast, Tom Jordan, you can readily get to that information. And then I mentioned about the Nature series. I'm going to try to find that as well. Nature debates, there it was. Get back to that. So there's a debate piece on Nature that people could also find if they're fascinated by this. So a series of articles over time that really delve into all the issues surrounding the topic of earthquake prediction. And so there are some people that still hold out a lot of hope for that. I came into the field of earthquake studies at a time when, there it is. Yeah, I came into it at a time when pretty much all enthusiasm and optimism had been lost by that time. So what happened there was that with the plate tectonic revolution, which really kind of got going in the mid-60s and went through the mid-70s, a tremendous amount was learned very suddenly about how the Earth actually works. So there are understood to be these belts where there was collision occurring called subduction zones, other places where the faults were moving side by side like California, called the transform boundary, and other places where the Earth's crust is spreading apart, like in the middles of the oceans like the East Pacific Rise. So all of this was rather suddenly understood, and it was called, for good reason, a scientific revolution with plate tectonics. And at the time it was thought that, you know, we have a chance now to predict earthquakes because we can see where they're occurring, we can understand it now. And also in the lab, people were putting rocks under compression and observing what happened right before they broke. And in those lab experiments, they saw that there was a phenomenon called tertiary creep, and there was all this microcracking occurring. It sure looked like there were going to be lab results that could align with things we would see in the field, and people thought we were going to be able to predict earthquakes. So this was all kind of in the mid to late 70s, I would say. And then in China, there was a successful earthquake prediction. People were able to get out of a town that then had a big earthquake, and it was very damaging. So that was a great success based on a very unusual earthquake sequence that got started and then culminated in a big event. And then not too long after that, though, there was a devastating earthquake also in China. So the prediction one was called Haicheng, and the big devastating one soon after was called Tangshan. So sort of just a very telling story of how, you know, we humans, we just we don't have the ability to predict earthquakes, but we try to get a handle on the physics of the earthquake source. And this is an area where we're making a lot of progress, where we are applying new technologies and learning a lot about how earthquakes work and how it relates between slip on the fault and the shaking that's experienced some distance away. So these are the kinds of things that we're making really good progress to understand.
We've got one more question. I'm going to hand it off to Scotty. I think he has a viewer question as well. But one myth I want to, I don't know about the spelling, but I guess there's some folks that think when you have a series, you talked about earthquake series, and when we have large ones in California, and all of a sudden there's one in Peru, and then there's another one over in Japan, and it seems like the media sort of steers it in direction like all these fault lines are becoming active now. Is this a sequencing event? This isn't something that starts in one place and travels all the way around the world across the maybe the Ring of Fire, or is that something? It's not like a triggering sequence all the way around, is it, or is it that just sort of random?
No, it's we have phenomena that we do understand to be earthquake triggering, but it's not reliable, and it doesn't really allow us to do prediction. But we do have people that are doing what we call stress change modeling, whether it be static stress change or dynamic stress change. There are certainly examples of earthquake triggering of many kinds. So, for example, when that Denali earthquake happened in Alaska, the one that I mentioned, as the waves were propagating across the North American continent, we saw examples where those waves coming through triggered earthquake activity, most notably in volcanic areas. So this is pretty well understood to be triggering. Sometimes when earthquakes happen in close proximity, fault movement on one fault can apparently trigger fault movement on another fault that's close by. And when I was doing my graduate work, I was studying earthquakes in Southern California, and there was, in 1987, there was an earthquake sequence that it started out with, I'm going to try to do this with my hands for y'all here, but first an earthquake happened on a fault like this, that slipped like this, and it unclamped part of this fault, and then it moved like that. So it was just a real simple case of static stress change triggering, and we wrote a paper about that, about how the delay between the earthquakes could be explained by the reequilibration of stress in the fluids and the pore spaces in the rock down there as one possible explanation. But just, you know, fascinating behavior of when one earthquake in close proximity can trigger an earthquake on another fault. So things like that give us some hope that we're at least understanding some aspects of earthquake system behavior. Yeah, and then other cases too, historically, where we've seen earthquakes that occur close together in space and in time, and it sure looks like some kind of triggering effect. So yeah, this is all interesting stuff, and people study the stress changes and the seismicity patterns, and humans have a natural tendency to see patterns even where maybe there isn't any real pattern. We just think we see one there. An example I like to give of that is that, you know, when you look up at the night sky and you see a pattern of stars, and, you know, that's how people came to name the constellations and draw diagrams and star maps and charts. But when you think about that, that's just human beings seeing patterns where really it's random. The stars are random, totally random up there. It's just we've made patterns, and we've used those patterns to great effect over the years for navigation, for you name it, just all kinds of wonderful things that through our pattern recognition and then using that, we've been able to, you know, in some ways figure out amazing things. But when it comes to earthquakes, a lot of it is just random fluctuations. And even though that may be a disappointing answer for some, that's the statistically correct answer.
No, it's still fascinating. I think we call that in the weather world, we call that teleconnection. So we're still young in our science and trying to figure out how patterns from around the globe are affecting patterns on the other side of the globe. So we're still young. We're tracking it. The technology is up and coming, and we're learning more and more every year. So very fascinating. Great answer, by the way. Thank you for explaining that. Scotty, would you like me to hand it over to you for a viewer question?
Yeah, if you want to. I was gonna, because I know we're a little bit past the top of the hour, and I'm not sure how long Kenneth can stay. But one thing we haven't really talked about is your project, Kenneth, that you've been doing with the Haywired fault and what you call the Haywired scenario. So maybe if you want to, for the next couple of minutes, kind of talk about that, and then we can get into a few viewer questions.
Sounds good. Yeah, I'm going to go back into screen share and get this up here. Let's see here. Okay, got it.
Yeah, if you want to stay on for a few extra minutes and go over this, don't feel rushed, because we would love to learn.
Yes.
So if I hit slideshow, just tell me verbally if that's working. Do you have full screen now?
Negative. We're not seeing that.
Okay, I'm going to try again.
Like I said earlier, the full screen option in PowerPoint sometimes has issues.
And while Kenneth's doing that, we'll kind of do a recap here. This is the Carolina Weather Group, show number 236, and we have Kenneth Hudnut on with us tonight. He is the Science Advisor and Risk Reduction Officer with the United States Geological Service, the USGS, and we're talking about earthquakes tonight and how they vary between the East Coast and the West Coast, and Kenneth has been working on a project called the Haywired scenario, and I think we may have it up here now, Kenneth. So I'll toss it to you.
All right. Can you see that now?
Now it blipped out. It came on for a second, then blipped out. So again, it might be that full screen option. If you just open the app itself and let it run as it's sort of without pushing play on the PowerPoint, it should come up.
Are you seeing my PowerPoint screen now?
Not yet.
Huh. I'm going to try turning it off and on again one more time here. There we go.
There we go.
Yep, there it is. There it is. And yeah, just manually click your slides on the I guess it would be your right side or whatever. So
yeah,
that works. I'm going to go ahead and present you to everyone, and feel free to go ahead.
Okay. I'm going to get my, there we go. Yeah, so the Haywired project is one that we spent several years on with a very large group of people. And what I'd like to do is just start out by mentioning this group and the people that were especially important to the success of this project. We just did a big rollout on April 18th, and many of these people were involved in presenting to the public this Haywired scenario. Dale Cox, project manager, Ann Wine, lead scientist, and many others, Keith Porter, Lori Johnson, they provided many of the chapters of this extensive publication, and we had a big team effort on this. We had a coalition formed of over 60 organizations as well. And at the end of the movie I'm going to show you, you'll see the names of all those organizations. But first, let me mention, too, that we did a fact sheet in association with that. It's available electronically, but also if groups are interested, we can ship out copies of this fact sheet. We printed a whole bunch of them, and they're freely available. Along with that, too, we did electronic publication of nearly 600 pages of a USGS report called the Scientific Investigation Report. Volume 1 of that report is on the hazards. Volume 2 is on the impacts. And all of that content is available at either outsmartdisaster.com or usgs.gov/Haywired. And also, if you look on social media, you'll find @HaywiredCA or #Haywired or #OutsmartDisaster. There's a ton of information, photos, all kinds of great information there. So this is, you know, as I said, the April 18th was sort of a midpoint, not an end point, but the work continues on volume 3. But I wanted to mention too, we're going to take a look at this movie, but we've had already over 80,000 views on YouTube with the movie, so we're feeling like, well, that's a good thing. One of the things we like to talk about when we describe the Haywired scenario is how in our project, the Science Application for Risk Reduction project, we always are trying to innovate. And so here what you're looking at is from the fact sheet, and it breaks down, and the couple ones that are circled here, these are all innovations of the Haywired scenario, but looking in particular, those red rectangles show you on the right column. We took a closer look at, for example, the water supply network vulnerabilities. And we did this in a limited way, not a comprehensive way for the whole Bay Area water system, but we looked at the parts of it for which we had good data and good collaboration with the operational organizations. And one of the things we're looking at is the vulnerability of the old brittle pipes, both cast iron and also what's called AC pipe, which stands for asbestos concrete pipe. And so basically, in intensity 6 or higher shaking, those pipes can fail. And that's a pretty serious vulnerability that we have. So, and there is a good mitigation option, which is to replace that older pipe with newer pipe, what's called seismic resilient pipe, or there are even ways to insert something that can then be inflated and solidified in place as a way of mitigating older brittle pipe. So there are ways to fix these problems too. The next slide here is talking about the disruption to the water service, and you see this in this graphic that from top to bottom goes toward prolonged outages at the bottom. So on the left side is if we had this scenario earthquake today, and on the right is if we had it after doing a bunch of mitigation actions. And you can see how water service would be restored more quickly if we took these mitigation actions that are mentioned in the report and described there. So that's just one area in which that's a great example of how if we do more work to be prepared, we're going to save a lot of disruption after a future disaster hits. Now here we're looking at the covers of the Volume 1 and Volume 2. As I mentioned, Volume 3 is in progress for October. And in the middle, this is our process diagram where Volume 1 is associated with the first floor, Volume 2 the second floor, and then the top floor is Volume 3. So the earth science hazard part looks at the landslides, liquefaction, ground shaking, fault movement, and we see in some cases the fault slips at the time of the earthquake, but then it can keep slipping, what we call after slip. We saw that in the 2014 South Napa earthquake in California, and we expect that we would have that after slip after a Hayward fault earthquake as well. So again, that's also something innovative about the Haywired scenario, as also with the aftershocks. We really never had delved into the long duration effects of fault after slip or a long duration aftershock sequence and how disruptive that could be. So these were other ways in which the Haywired scenario innovated. And when it comes to the engineering impacts, we also looked at lifeline interdependencies, fire following earthquake, the building codes, and how those could be improved, and how actually the public is quite in favor of that. And then in the upcoming parts, we're going to be looking at communities at risk and telecommunications, all these things where we have serious vulnerabilities. And the reason for the name Haywired, wired meaning like Silicon Valley internet, and so we've grown in our reliance on the internet, of course, in the recent decades. We've actually never had a big urban earthquake since the age of the internet, which I guess you'd say is about the mid-1990s with the World Wide Web. And so the last big significant earthquakes in California were 1994 Northridge down in LA area and 1989 Loma Prieta up in the Bay Area. And we'll come back to those in a moment. But just to say that a lot has changed, especially in the internet arena since those big significant urban earthquakes. I'd like to show this movie now. I hope it plays well for all of you out there. And I'm just going to go quiet while the movie plays here.
The Hayward Fault, one of the most urbanized and dangerous faults in the United States. Millions of people live, work, and travel near the fault each day. There's a large earthquake on the Hayward Fault about every 100 to 220 years. The last one was 150 years ago. It's coming, and when the Hayward Fault ruptures, the roads, the pipes, the wires, the things that connect everyone to people and places will go haywire. The USGS and its partners have created a comprehensive, detailed analysis based on the latest science, a scenario depicting what might happen in a magnitude 7.0 earthquake on the Hayward Fault before it happens. This gives us a chance to envision our vulnerabilities and a chance to prepare. This new scenario is set on April 18th, 2018, the anniversary of the 1906 Great San Francisco earthquake and fire. The following scenario explores the possibility of a Hayward Fault earthquake. It is not a prediction, and a real earthquake on the Hayward Fault could occur at any time and may behave quite differently. April 18th, 2018, 4:18 p.m. The earthquake begins. With an epicenter at Oakland, the rupture races 52 miles along the fault towards Fremont and Richmond at speeds of 7,000 miles per hour. In Berkeley and Hayward, the ground shifts 3 to 5 feet, ripping through buried pipes and wires. The USGS shake map shows areas of violent and extreme shaking, lasting up to 30 seconds or longer, causing very heavy damage. Away from the epicenter, a warning arrives up to 25 seconds before strong shaking begins. Impacts and destruction are magnified by a cascade of hazards. In the Haywired scenario, 800 people die and 18,000 more are injured. 2,500 people need to be rescued from collapsed buildings, while another 22,000 are trapped in elevators. In this scenario, 77,000 to 152,000 households could be displaced. Some East Bay residents lose water for 6 weeks and up to 6 months in the worst hit areas. Lack of firefighting water could turn some of the more than 400 fires into conflagrations, burning the equivalent of 52,000 single-family homes. Who has power, water, gas, and communications? Every lifeline is disrupted to some extent. This could be the first major US earthquake in the age of the internet. What happens in a disconnected world? Dozens of significant aftershocks and fault afterslip will cause additional costly damage, requiring repeated inspections and repairs. Property damage and direct business losses exceed $82 billion, mostly due to shaking, but also to liquefaction and landslides. Fires could cause hundreds more fatalities and an additional $30 billion damage, and would extend the duration of disruption. Few things are insured. How many people will move away? What will such a disaster mean to you, your family, and your community? Acting now can save lives and jobs, businesses, neighborhoods, and homes. The Bay Area has invested over $50 billion since the 1989 Loma Prieta quake, strengthening potential points of failure, infrastructure, and buildings. But these efforts need to continue and expand through your engagement. Use the Haywired scenario. Doing so will reveal actions that will lessen business disruption and improve our ability to bounce back. More actions like these will reduce risk, and creation of the Haywired scenario offers you an opportunity to do your part. Partners are continuing to come together to share interdependencies, resources, and solutions. Use the science. Come together, because together we can outsmart disaster.
Well, there you have it, and it's going to roll the credits now, and I just like to let it roll with it's got that list of all of our partners in here for one thing, and you know, like I said, it was a big team effort. So I mentioned it's on YouTube, and I'd encourage people to go there and find it, or you know, I hope it played well for everybody. If not, you might be able to get it to play at higher resolution or something by getting to, you know, do it again. I mentioned also about that fact sheet that we've made available. I hope people will go find that online as well. It's kind of a 6-page, easy step-through guide to the whole contents of the 600-page report. So here I've got in front of us now, I'm going to keep going quickly through the rest of these slides for you. I mentioned about the San Francisco area Loma Prieta earthquake of 1989 and the Northridge 1994. And I think in the interest of moving through quickly, I'm just going to step through here. But basically, some of the things that were mentioned in the movie, I just want to come back to quickly. But 800 people, that's a lot of fatalities that are foreseen in this scenario. And it's just one representation of what could happen in one possible earthquake. The way that we do such estimates is using software, what's called HAZUS. And this is something that for us, we kind of do this all the time. We talk about this in our meetings, and for us, it's just kind of normal to talk about large numbers of fatalities like that and large economic impacts. But what we're trying to do here is share that kind of thinking with the public, not to scare them, but to hopefully make them feel empowered and that they have the knowledge that they need. And we are hoping that people will get more prepared as a result of hearing this information from the scientific community. You heard about how tremendous investment has been made in trying to reinforce and make society more resilient against earthquakes. And since the 1989 Loma Prieta earthquake, over $50 billion has already been invested. And what you see here is the Bay Bridge. This was $17 billion right here, this one project. Of course, a very important transport corridor. And you see the damage pictures from the 89 Loma Prieta. You may remember that was the World Series earthquake, as it was called too. And over in the peninsular San Francisco area, the Marina District, as it's called, there were a number of buildings, 6, I think, that apartment buildings that collapsed. And this was a common problem that those shared, of having dry rot in the first story, and also a soft first story, as it's called, where they would park the cars on the first level and have the rigid wood frame up above. So in the shaking, these just tilted and leaned and then fell. And in one case, you see in the upper left, the one that's burning, the rigid gas line broke, and the building had fallen out toward the center of the intersection, and it had covered a fire hydrant. And so the gas was leaking, and it very suddenly burst into flames. And this was just a tragic story there of one woman that was trapped, and they were not able to get her out before the fire engulfed the building. But this is a repeating pattern too. With the 1906 earthquake, there was also liquefaction and ground motion amplifications where you have soft soils. In the Haywired scenario, we would anticipate a pattern of damage that looks like this, where here we've combined all the different threats from the earthquake: the shaking, the fault rupture, the fire following earthquake, and also other things that would cause people to potentially need to displace from their homes. And you can see here complete damage state. 20 to 60% damage state is the orange, and there's an awful lot of that along what we call the East Bay corridor over here. The cities of Oakland, San Leandro, Hayward, Union City, Fremont, very heavy damage through there. And so for everybody local, they know this means really bad news in case of a future earthquake on the Hayward Fault. And we're doing this partly because we are coming up on the 150th anniversary, and we'll be commemorating that. The 1868 was that last big earthquake on the Hayward Fault. So this fall, October 21st, there will be a large earthquake sort of preparedness engagement at Fremont Central Park. And just a couple last thoughts here. What we anticipate from the Haywired scenario is that as many as 152,000 households, that's about 411,000 people, could be displaced. And we've seen in the 1906 earthquake and fire, and then also in Katrina, numbers on par with that in Katrina were displaced. And just to give us a scope and scale to that, with the current estimates we're seeing for Maria, Puerto Rico, it's probably more like 100,000 displaced. So four times as many in Katrina, and this Haywired scenario would displace about that same number. So imagine the Haywired scenario and displacing people on par with Katrina. That's just really concerning to think about that number of people displaced. Now, it kind of went past fast, and I didn't mention this quite enough earlier, so I'll say now, but we have this line that we're using. We say, together we can outsmart disaster. And so this started with the Haywired scenario in the Bay Area, but what the state of California is doing now is turning this into a statewide campaign called Outsmart Disaster. I mentioned the outsmartdisaster.com website is a place where you can get a lot of resources for this. And this is a public-private partnership that the state is starting off and expanding statewide. And so this is led by a part of the state government that is they house the California Seismic Safety Commission, and it's led by Secretary Alexis Podesta. And so her team, Lynn von Koch-Liebert and others, are turning statewide with the Outsmart Disaster campaign, and we are looking forward to supporting that. And but it's really led by the state of California, and we're just very impressed with what they're doing on that. And I just wanted to mention that in closing. But that's the end of my presentation right there. I'm just going to close that down.
Kenneth, the video I watched a few days ago, and then watching it again, the statement of this would be maybe the first major earthquake during the age of the internet. We kind of saw that per se last year with our hurricane season. It was the first active hurricane season with the invention of social media. Social media really hadn't taken off in 2004, 2005. So, that's a good point about the age of the internet, and just how we all depend on the internet to communicate and to do our everyday lives. So not having the internet, especially in California where a lot of trade and commerce goes on, would be devastating not only to your area, but to the country and even around the world.
Yeah, and there's some really important pieces of the internet in Silicon Valley. We have similar concerns in LA where, our infrastructure is vulnerable, and there are steps that we could take to make it less vulnerable, make our society more resilient. In terms of the internet, that's one of the chapters that's being worked on for Volume 3. There was a workshop held where we actually used another innovative approach, what we call design thinking, which some of your audience may be familiar with that. But there's a whole structured approach to eliciting good ideas from people. And this was a workshop in where we tried that approach and applied it to the issue of telecommunication vulnerability. So that's coming up in a chapter that's in development right now. The lead author of that is Ann Wine, who I mentioned. And another workshop that we did in that same way was on the aftershocks. And Ann Wine also is the lead author of the chapter on aftershocks. Now, Ann is from Christchurch, New Zealand, where they had a huge problem with aftershocks. And there was the largest earthquake of the sequence was outside of the city by just enough. So there was damage in Christchurch from the main shock, what was called the Darfield earthquake. But then it was these large late aftershocks that happened closer to the central business district that did really the worst damage. Part of the Haywired scenario addresses that possibility of a large late aftershock, and it's because of the experience from Christchurch. So we're, like I said, we're drawing information from earthquakes that happen everywhere around the world and trying to pull that in and use that as lessons learned. And so whether it's the earthquake in Gorkha, Nepal just a few years back, in that case, we just keep learning a lot. And these earthquakes, I guess if there is a silver lining to these disasters, it is that we can learn from them and we can get better at response and recovery too, which is so important. So I know from having seen some of your program, I really respect how you guys get that coverage in there about how people do emergency operations. And I think this is another area where we actively share across the nation. And right now here in Hilo, we've got a team deployed out here from North Carolina helping to manage this incident with us. So incident by incident, we do our after action reporting. We fold that back into the planning cycle. We update our plans and exercise again, see what goes wrong this time. And that way, every time there is a significant impact to us, wherever it may be, we get better at responding together.
We're just stewards of the science, passing on the word and making sure our audiences get the latest information as it pertains to emergency and disasters. So it's really great to have an earthquake specialist on to talk about some of the more global aspects. I mean, wow, this is a plethora of information. One quick question I had for you was, okay, out of all this information that's available, we can go to websites to see a lot of this information. Does the USGS have phone apps that alert you when there's earthquakes? Is there a modern sort of technology field that you guys have that the public can get as well?
Yeah, I'm going to pop up a tab here and show you exactly what people can do if they would like to get alert notifications from the USGS. It's called our Earthquake Notification Service, ENS. And I see here the link is actually earthquake.usgs.gov/ENS. And we can just go there and take a quick look. Okay. Sorry for the pop-up windows coming here, but just basically you can set up your own account here and you can set up your own profile. So for example, if you care about earthquakes worldwide, but not the smaller ones, just the bigger ones, then see, I make sure I want to screen share again here. Sorry, just take a moment. Are you seeing that now?
I think we got Shay up for you. So he's got the ENS page up.
Oh, okay, thanks, perfect. Yeah. So say you wanted to set your profile to pick up everything above magnitude 5 globally, and within your area of interest, let's say East Coast US, you want to also get notification if there's anything above magnitude 3.5. You can set up your own profile and use that interface to configure it the way you like it. And let's say, for example, you configure it a certain way, and then you're a week into it, and you're thinking, boy, I'm just getting too many notifications, and you want to dial it back. Well, you can just go back in there and tweak your profile. So this was all set up by my colleague in the Pasadena USGS office named Stan Schwartz. So that's a little shout out, Stan, and thanks for all you do. We also have a tweet earthquake dispatch. Paul Earl in our Golden, Colorado office has made great use of Twitter. It's quite commonly the case in many parts of the world that the seismic network is a little bit sparse. And so this is now implemented in many different languages. So if an earthquake occurs someplace in a especially where there's sparse network coverage, oftentimes the very first thing that will happen is you'll see it just slamming on Twitter with a whole bunch of tweets out there saying earthquake or terremoto or in all these different languages, and that Twitter earthquake detector will pick them up. And Paul's been making quite a study of that, and this came into play actually with the Mineral Virginia earthquake as well, that you can watch movies online, you can go find them and see how the earthquake waves propagating out are also seen as tweets propagating. So you see that it's like throwing a rock into a pond, and you see the circular ripples go out. And when an earthquake happens, you can see the tweets going out like ripples on a pond. It's pretty cool.
Yeah, Ken, I was in Reston for the mineral earthquake, and I was born in California, but that was my first real big earthquake, and I was like, well, this is backwards. But it was fascinating because I wanted to join the throngs of people tweeting earthquake, but there was no internet. So I had to text 40404 and say earthquake. And then after that, I texted my wife, make sure she was okay. But it was we go back to talking about, internet disruptions and everything like that, and infrastructure disruptions, and being resilient with that, very similar to what we saw in Northern Virginia. There is a lot of infrastructure. You have a lot of internet companies that, Amazon Web Services is up there. You have, they had the derecho come through about a year later, a year after that, and it brought down the US East 1 region. And so Netflix and all sorts of other applications who didn't have failovers to the West Coast, they just went offline. It was like Netflix was down. It's like they had this terrible storm in DC, and you couldn't even watch any, and you couldn't watch anything basically across the entire East Coast of the US because they didn't have the failover. So I think it's really important. As you mentioned, in Silicon Valley, same problem. Tech companies and businesses need to understand that disaster recovery is not just the one that's local. It's not just the hurricane that hits your office. It's potentially, where is your infrastructure? So
on that point, that's a great point. And I think what we've seen in earthquakes worldwide is that the internet is more vulnerable than people may realize. So, if you're quite knowledgeable about the internet, then you know that it does have failover capability, and you have lookup tables so that if one connection to a particular server goes down, then that'll fail over and you'll get another one. They're lookup tables essentially. And so the thing is, though, it is a bit of a misconception that the internet is super robust. It is robust. It has failover capability, but that doesn't mean it's just going to always work for you. And we've seen in big earthquakes quite significant disruption to internet service. And partly that's vulnerability of our, let's say, cell towers or fiber optic trunk lines, that kind of thing. Imagine a fault rupture. At one place in California, there's a place where the San Andreas fault goes through, and there are fiber optic bundles that cross at this point, and we imagine that in a future earthquake that fault rupture going through that one place alone could lead to very widespread disruption. And so, yeah, these are things that are concerning, and there are ways to mitigate. So, for example, one could imagine doing something like an engineering design challenge and say, okay, here's where some lifeline infrastructure crosses a particular fault. How could we, with a certain budget and timeline in mind, how might we go about making more resilient fault crossing infrastructure here? We have great examples of for example, up in the San Francisco Bay Area, SFPUC, where they have water coming to San Francisco, it crosses the Hayward Fault in a very large diameter pipe. at a place called Warm Springs, and they've put in this incredibly clever rearrangement of the piping and with joints and so forth so that it can accommodate fault movement there at great expense. And they've also put in interties where the different water system lines cross each other. They've made it so that they can connect them, and it requires operation of valves in order to make those switchovers. But these are ways in which existing infrastructure can be made much more resilient, but we do have to think ahead and spend some money ahead of time before the disaster in order for these things to work well after, or during and after.
Well, Kenneth, we appreciate you being on with us, and man, what a great show. And who knows, we may ask you to come back and we talk more about earthquakes. This has been a fantastic show and a lot of information. We've been tweeting a lot of stuff that you've been talking about. We did share the YouTube video that you played, so hopefully a lot of our followers can get that. And right now we'd love to give you the opportunity to give out your Twitter account, maybe where our listeners and followers can follow along with you and ask you any questions they may have.
Yeah, that'd be a great way for questions to come in. And then it's totally unofficial, though. It's just a personal account, but I'd be happy to take questions there. It's at KW Hudnut, Hudnut. So yeah, oh, there's my family right there. Very proud. So yeah, as you can see, there's nothing USGS about that Twitter account at all, but just please do feel free to ask questions there. There's also, of course, there's at USGS, and then there are several other accounts I'll mention on Facebook. There's also USGS Natural Hazards, and I would encourage people to go check that out. And right now with the Kilauea eruption going on, that would be a really great place to pick up updates from the USGS Hawaiian Volcano Observatory as the activity continues here in Hawaii. And when there are big earthquakes or other disasters of any kind, natural disasters, you'll find great information here. So yeah, please follow this group and get your information right there.
Well, Kenneth, we again appreciate you being on with us tonight. Thank you so much. And Shay and I will stay in touch, and hopefully maybe we can get you back on and we'll talk a little bit more about earthquakes because, as you said, it's always a changing field. So we're always looking for new answers to our questions.
Great. Well, thanks. It's been a pleasure working with you all. And I think just as a parting shot, I just want to show you that view one more time.
Yeah, please do, because I've been to Hawaii and Oahu, and I love Hawaii. Gosh.
It looks like you looks like there's a shower developing behind you.
Yeah, they could go.
We're gonna have to zip over there, Jared. Let's get a webcam and we gotta do some coverage.
Let's do it. Yep.
There it is.
Breaking weather news: we have a shower in Hawaii. More importantly,
one thing I'll say, pass along. I'd like to pass along the news from Hawaii, which is important to the people here, is that the Kilauea eruption is very serious for an awful lot of people, but it is also it's limited to just a small part of the island, and the tourism is just fine. You know, Kona, Hilo, most of the island is really unaffected. So I hope people will not cancel plans to come. It's a gorgeous place and still open for business over here. So come on down. Awesome. Keep your vacation plans. And the national park is closed almost completely, but there is one area of the park that is being kept open. And then there's just an awful lot of need here too for help. So if you have it in your heart to make contributions, please consider that too.
I'm trying to find that tweet from Brad Panovich on that very topic. And give me a second, Scotty. I want to slide this up. I know we got to get going here, but he just nailed the really good topics. I'm scrolling Brad Panovich. He did a good example of what people think about what's going on in Hawaii and what's actually going on in Hawaii. Because we want tourism to still thrive there. We don't want people to be scared to go. It's just limited to one small part of the island. And I'm not sure. He's got a ton of tweets, Scotty, so it may take me a minute, so go ahead.
I think I know that map that you're talking about.
I was going to say Brad tweets a lot. So well, while you look for it, I'm going to go over our schedule for the next couple of weeks, and then hopefully by then you've got to the tweet. But next week we have Dr. Philip Klotz back on with us from Colorado State University. He's going to give us a this hurricane season preview. We normally like to do that beginning of June as we kick off hurricane season, but Phil had some things to do. So happy to have him with us next week as we kind of preview the hurricane season. The next week on the 27th, we have the Sirens Project. This is a group of guys out of Atlanta, Georgia. They are based there, and they go storm chasing with their drones. So looking forward to talking to Warren and his crew about their adventures they've had out in the Midwest this year, chasing tornadoes. And then we're all for the 4th of July. And then we kind of pick back up on where we left off tonight. We're going to be talking about volcanoes with Dr. Janine Kreipner on July 11th. She's going to be kind of giving us the in and outs of volcanoes, and I'm sure we'll talk about what's going on in Hawaii. And then on the 18th of July, we will be talking about tropical tornadoes with Roger Edwards from the Storm Prediction Center in Norman, Oklahoma. So that's a look at the next 4 shows for the Carolina Weather Group. And again, you can always find all of these shows on our Facebook page on the event side of things, as well as our Twitter account. And again, go give Kenneth a follow on Twitter. Some fascinating information tonight about earthquakes and the Haywired project, and just looking forward to more information. And Shay, did you find the tweet?
Man, no dice. I'm scrolling, and I didn't realize Brad actually tweeted this much until tonight. So, but he does some no nonsense kind of very simple, basic, like things kids could understand in like elementary level graphic designs that everybody understands, and it's just so simple, basic, and it just shows you the scope of it. And
we'll let Shay retweet that once he comes to it for his tweet of the week, and that's what we'll do. So for everyone here at the Carolina Weather Group, we hope you have a great weekend. Seriously though, it is going to be heating up here in the southeast over the weekend into early next week, probably seeing the hottest temperatures that we've seen all year long, and at least all summer long. So stay hydrated out there, and we will see you back here next Wednesday night on the Carolina Weather Group with Dr. Philip Plotzback as we talk about the hurricane season. Once again, Kenneth, thank you so much for joining us. Enjoy Hawaii. Don't work too hard out there.
My pleasure. And if I could screen share one more time, I found that one that you're looking for. Try to do it quick here.
Kenneth beat you to it, Shay. How about that?
There it is.
There it is.
Yep,
what people imagine.
Yeah,
that's a classic. It is a tiny little area where this is occurring, and it's been very disruptive to the people that live there already, as I'm sure you've seen. But yeah, it's not like the image on the left. People over in Kona are wanting to make sure everybody knows that that everything's just fine over there. And Hilo, when the trade winds are strong, as it has been lately, the wind blows offshore toward the south-southwest. So all the gas is blown out over the ocean instead of toward Hilo. So it looks like I'm hearing that we're setting up for a change in that, where the trades are going to back off a bit. And so some of that volcanic gas is going to probably be lingering a bit more. But anyway, that's what I understood from the NOAA National Weather Service report here. But anyway, thanks again. It's been a real pleasure working with you all.
Yes, it's been a pleasure. And anyone who's going to Hawaii and you have an extra seat, I'm available to go with you. So anyways, everyone, have a great weekend. We'll see you back here next Wednesday night for the Carolina Weather Group, or with the Carolina. We'll see you next week.
I'm ending the show. All right.
Thank you all.